contacts for the whiskers. And in the end, it kind of looked like this demented cat.
Oh, sweet.
Got his whiskers.
I don't know, Ken, is that a win or a coworker?
I don't know. My brother thought my brother and nephew thought the ears looked a little bit big, and their cat definitely did not approve of my cat. They said it more looked like one of those demented rabbits from like a Monty Python movie that eats your neck or something.
Special form of evil with that cat.
But
you need to give us a picture of that.
How do I send it to you?
Just send it to me by email, or actually send it to education@parallax.com, and Stephanie will plop it into the presentation.
Okay.
Yeah, I was going to say, with the way I did my background here, it's hard for me to show my robot on the screen. Would you be able to bring it up on your screen when you do that?
Yeah.
Since I sent you a picture.
Yeah, I got the video. That's fine.
Okay.
Yeah, and so this is the...
I
got
can't
it.
get this off.
Queued up, as a matter of fact. Good.
Okay, that was education at Parallax.
Yeah. Stephanie, you can put that on slide 4 or 5.
I'm looking for the slideshow.
I just shared them to you, I think.
And I gotta remember how to spell parallel.
Parallax.
It's like so much stuff is happening in real time these days.
Yeah.
I think this would be near impossible without Google's tools as well as Zoom for us to function. You know, just being able to share things back and forth so quickly. Like, think back to the olden days of sharing files. And
yeah, well, I was just kind of happy when I finally kept getting and having to like then bridge from one breadboard section to the other, and I've got all these little wires running everywhere, so that I can try to fit all this junk on, so that, you know, it's that wonderful first Lego mentality. If I can have one sensor on here, I should be able to have 2 sensors on this robot, and dang it, it's gonna work.
You can load that thing up with everything in your kit, is my belief. It gets tough, but it can be done.
Well, I found that, also noticed that now my ultrasonic sensors kind of point down, so they were seeing like my phone on the edge of the desk with the electrical tape under it.
Yep.
And if I took that away, it could see all the way to the wall at the other side of the room.
Yeah, yep.
It was like, oh, so it's, you know, finding out how tight that actually was on its focus beams was rather impressive. Let me find where I got that rabbit.
Ultrasonic Sensor is a wonderful thing to have in this kit. It's one robot where we really load up the sensor offering.
I couldn't not do it.
Because it can handle it.
Okay, I'm just awaiting a photo of the demented rabbit.
Jeffrey, are you sending a photo? Oh, you already did?
It's making its way.
I'm working on it. I gotta find it.
Okay.
Okay.
Yeah, I've got my camera to work, so I have a feeling where my problem is this is angled down a little bit.
Let's see.
It might have been catching the floor.
Oh, yeah.
This part.
Yeah.
Behind there, but
probably hitting the Legos in front.
That's probably more likely that it's just occasionally hitting the edge of the roof there.
Oh, okay. I wonder if I just took this top part off and check it. I'll try that later.
Yeah, there's lots of particular geometry.
Okay.
Sometimes even the cardboard around it can cause some audio reflectivity. Like we've built, I built those into a chassis of a robot, then they were tight fitting and they didn't work. So the canister around it, I really don't know if it's dependent on that or not. The transducer's inside, but I had one project where I put the transducers into aluminum. Didn't work.
We're losing your bandwidth, Ken.
Lovely.
Do you need to like close Hangouts or something?
Yeah, let's get rid of some stuff. Thank you. You're right. Thanks for looking over my shoulder.
Another story about the ping is one day I came into the office and Stephanie waved me into our conference room where she had a robot that was doing ping sensing. And she told me to turn on the light. And when I turned the light on, the ping sensor went from 3 meters to like 4 centimeters. And I turned off the light and the ping sensor went back up to 3 meters because it was pointing off into space. And so we were looking at each other thinking, okay, the ping uses echolocation, it's sending out sound, yet I'm turning on a light and suddenly the ping is getting nearsighted. What on earth is going on? Anybody want to hazard to guess? I see Alan talking, but you're still muted.
I said reflections and then decided that wouldn't work because that has nothing to do with the sound.
It's true, and that's what we were scratching our heads over. We eventually figured out that the ballast that was making the fluorescent light, giving it the high voltage it needs to fluoresce, was making a 40 kilohertz ultrasonic pitch that we couldn't hear, but the ping sensor could hear and thought it was the reflection of its own echolocation service. So that was kind of an interesting one. How you doing, Ken?
Doing good. We're just,
All right.
I'm still getting things prepared. So 5 more minutes, we'll get going.
Hey, Jeffrey, could you share that with S. Lindsay, SLINDSAY at parallax.com? Otherwise, it's asking me for an education address login that I don't have. So I'll put
How
it
about
in the.
now?
Okay, let me refresh that. Inbox. There we go.
Did it work this time?
It appears to have.
I have a question.
Whoops, I think I sent you the wrong one.
Oh, I've got a nice side view.
Yeah, let me send you the Demented Rabbit one.
What's your question, Steve?
Okay, so I created a program with the ultrasonic sensor that would run repeatedly. It'd stop 8 inches of the wall, back up, and then either turn left or right at random, and then also would turn a certain distance at random too. So sometimes it might turn 90 degrees, sometimes it might turn 15 degrees.
Uh-huh.
But what I wanted to add was a sound feature, and I can't find any place on anything I've looked, it shows us how to program using sound. Is there
Okay.
a good
Yes, there
tool
is.
Oh,
someplace?
Yeah, I pulled today. It was a common question. Actually, 3 of you wrote in asking about sound. So I'll have a sound program up for you today that I will also distribute.
Okay,
Yeah,
good.
and anyway, it's in the short answer is there's an audio set of blocks.
Yep.
And there's a frequency out block there.
Yep.
So go grab that. And then, but really to make use of this, you should really also use arrays if you want to play a whole song.
Okay.
So there's
rather than-
there's a tutorial in the Blockly tutorials on making sound and music, and there's also a multi-core tutorial so that you can cause another one of the propeller's processors to play that music while it is still navigating.
Okay. I didn't find that. I looked. I guess I didn't find that.
Stephanie, can you post links or do you want me to?
I can in just one moment. I am amending a slide.
Ah, okay.
Apparently she got the Demented Rabbit.
I sure did.
It's a good thing that's not the last thing we see before we go to bed tonight.
Yeah, well, my brother sent me a real cute picture of his cat just staring into his phone going, are you, with a just total look of, are you insane sending me this? Apparently the cat really was not impressed with my poor little rabbit.
Hey, 5 after, why don't we get rolling?
Okay, I added slide 6. Tell me if that suffices for you.
It looks fine.
Okay.
Just gonna check and see how many people we've got in here on this one. Oh yeah, I think we're mostly here. We had to lose a few to administration meetings that they were not enthused about attending. Sense that. And let them know they would get a video afterwards. But it was more difficult for them than us because we're obviously programming robots and they're sitting in a more boring Zoom meeting by a long shot. All right, everybody, welcome back to Thursday. We're having fun, right? Yes. I can see it, even though sometimes I can't hear it. Okay, so today, we really want to address your needs through the day and then just fill in any little voids. I do have a loose agenda, and it goes like this as we wait for this slide to advance, and my computer may be having trouble. Stephanie, let me know if my audio goes away.
It's kind of on the
You-
edge. And
Oh.
you're still logged into Google Hangouts. I still see you
Okay.
active there.
Oh, yeah, that's interesting because I logged out of that a while ago.
Another test we might try is to find out whether if you have your Wi-Fi connection going to that one robot, if you were to close that down, does that make a
Oh
difference?
yes, to that
Certainly a
I am-
possibility.
I am wired. I can turn that off. That is off. And Hangouts is closed. So we
And-
should be good.
You
Ken,
definitely
do you
sound
use
better.
a Chromebook?
With the Wi-Fi adapter, do you still need to download the launcher program?
Yes.
Yeah, same process.
Okay.
Yeah, there's actually a video, and we'll try to get that video posted today. I put it on YouTube the other day. So it looks like, as long as you can hear me, I think Hangouts, not Hangouts, but Google is just having an issue with the slideshow. So we will just show it in this view. Full screen is not working, but you are seeing it, right?
Ken, are you using a Chromebook?
Nope, I'm on a Windows Surface machine.
Okay.
Yeah, so just to verify, you can see my screen, right?
Yep.
Okay. All right. So our agenda today. Want to see who's built what from homework, light following infrared or ultrasonic, hear about successes, failures, questions, and then 3 of you asked about sound. So I have a sound program up. I'd like to show you that uses arrays that makes this whole thing a whole lot easier. Inevitably, you're going to have students that are in band, and this is a great tie-in. So let's give them somewhere to go. Sound is one of those places. And after that, we're going to do a graphing project with the ping. This is something probably not used in our ActivityBot tutorials, is it, Stephanie or Andy? And the reason I want to bring it up is because you're all using the ping and having, some various trouble. I want you to be able to see what it sees. So we will use graphing to demonstrate that. So you'll be hooking up a ping. If you want to get it handy now, that's great. And then we're going to look at some of the advanced projects with the ActivityBot. And then finally, how do you teach with this? Like, okay, we've given you just enough skill to wire up, write some code, and we've gotten over some hurdles. But what now? So what do we have to help you along, and how do you unroll this in a class? So we'll go over the Parallax resources for that, and then how to get support going forward. Because I think you guys already have the right impression about us. The people you're talking to have been doing this for 20 plus years, collectively probably 60 years. So we're here for you, and we're not going anywhere, and want you to succeed because we believe that this is the class your kids will remember. This is it. Ask me what I remember. It was programming in middle school on a Timex Sinclair, and then I think it was the workshop in high school, stained glass, Stephanie, something you'd enjoy doing.
I did.
Yeah. And we have the award ceremony. So anybody move to ratify and approve our agenda?
I second the motion.
Oh, you guys are all formal. Okay, so let's talk about some of the projects. Give us a thumbs up if you built ultrasonic. Okay, all right. Did you succeed with that? Another thumbs up. Visual or, yeah, the button. Okay, good. How about visible light following? Okay, some of you just kept going. Wow, all right. And then what about infrared object avoidance? Anyone build that tricky circuit? Ah, Sarah got it. Okay. All right.
From Chris.
You see a few more?
I mean, I tried it, but I couldn't get it to work.
Okay, and that's Sarah, right? Okay, so let's
Yeah.
use Sarah's Let's start with what Sarah got stuck on, because others will get stuck on the same thing. And this is a circuit we've used in all of our robots, regardless of processor. Just
Is
briefly
there any
what it
way to have
does, or how.
Sarah hold her robot close to the screen if we do some troubleshooting, or is that?
Yeah, Sarah, do you still have it built by chance? Oh, it actually
yeah.
looks.
I still have it built. So, well, so when I tested it for the infrared part, for this part, it just stayed like, at first when I tested it, it would flash 1, but then just, but then it would just stay on 0. And then it said not time, because I just figured it was too bright in here, maybe, and maybe that was the problem. So then I fussed around for quite a while just trying to get on these red lights to them light up. And literally I took everything off this board and then put everything back on the board, and I kept going back and the picture like every one of these things were in a right spot. And I still cannot get these red lights.
To be
actually do
indicators.
anything.
Mm-hmm.
So you can
Yeah.
kind of, they are where everything is on my board.
Okay. All right. Is the audio okay?
Mm-hmm. Yeah.
Okay. So Sarah, probably the errors we see with this, actually, it'll be frustrating, but it relates usually to circuit building. It's a tricky one to build. And Andy, do you want to give some tips on it?
Okay, so for the circuit, certainly the longer pin is one gotcha. And if you look at the upper of the 2 cylinders, the one near the 5-volt connection, I think one of the difficulties is seeing the fact that it looks like we're straddling the infrared receiver. So the long
You
pin,
just went out.
sorry, your bandwidth is kind of low, so I couldn't quite hear what you said.
Keep explaining that, Andy. I think it's useful.
I can't hear you.
Okay.
Oh, her bandwidth.
Yeah. So
Maybe stop your
Can
video.
you say that again?
So the cylinder that is closer to the 5 volts, the infrared LED, its longer pin is going in one row above the infrared receiver. So it's the second breadboard row from the top, the same one that blue wire is plugging into and going down to D/A0 at the way bottom. Then the shorter pin is the one that's going in below the infrared receiver. So that's 1, 2, 3, 4. It's the 5th row down. So getting those ones in the right spots is one potential gotcha. Another potential gotcha is if you have a fluorescent light that's generating a lot of infrared interference, flashing at 40,000 times a second-ish, that can cause false detections. A third one is definitely in the program, checking all your variables, make sure that every number is correct. Because if you have one number that's not correct in the program, it can, basically cause the test to fail.
So often in Blockly, when you're copying and pasting code to save time, we don't change the constants, and that's a problem. So something there, we're certain that the individual pieces can be made to work. Maybe it's your circuit, maybe it's your code. You could also send us over your code and we can look at it. And we'll help you get this working. Anybody build the infrared circuit successfully and get some roaming going with the robot? Yeah, it's a trickier one, and it occupies a good chunk of the breadboard, so we're not totally surprised you didn't get there. How about the light followers? Anyone do light following? light following thumbs up if you did it? Okay, so ultrasonic is pretty much where everybody went, it seems like. All right. What I think we should do then is, good. This is kind of matches what I'd planned. Let's actually look at the ultrasonic sensor alone and use graphing to see what it sees. So then you could really see interference quickly after you write a program for it. With this fun sensor, everybody does what you did. We put it next to different surfaces, and it might be low to the ground. It might have things around it that could all interfere with it. So I'd like to build a program that has just the ultrasonic sensor and uses graphing. So I'm going to switch over to this program that I've made, which you can see, and I invite you just to wire up the sensor. So I'll give you a picture of it. I'm going to get it straight out of the reference guide by right-clicking on it. Here's an example, and if you have this built up right now on different pin, that's totally fine, but it's easy to wire. It's just power ground and then a resistor to the IN. So just take a minute and build that up. Or if you already have it built, you can just leave it there. And while this is going on, we can take questions too.
I have a quick question. Hi. So I was able to build the Sonic version, and then I was able to test it. I jumped to the third one where it can where basically it keeps its distance, and it can run that now. But then when I want to go back and try to upload something else, it seems like it won't let me load anything else. Like it just tells me it fails. Is there anything I might have touched or moved where
just
it won't
want
let me load anything else?
Yeah, let's verify when you try to load, you are on, right? And switch position 1.
Yeah.
Okay, and you're just getting download and then fail. And does it work once in a while, or does it just consistently not work?
It fails now all the time.
Curious about your internet connection too.
That happened to me last night a few times, and I ended up having to unplug everything from my computer, close down my program, and then restart it, and then it worked. Happened twice, and doing that this morning, it hasn't happened at all.
Okay. I have a hunch that some of this relates to Chrome. Andy, do you think this could be also a Chrome resource usage issue?
Yeah, it could be a Chrome resource usage. It could be if we have a Mac and an older Blockly Prop client. There's a new Blockly Prop loader for updated Mac operating systems that might, it may have been when you unplugged and plugged back in that the older Blockly Prop launcher / client had some problems with the new Mac operating system, and we just recently put one up.
And Marco, you're on a Windows machine, aren't you?
No, right now I'm on a MacBook. So,
okay, did you get
I've gone back and forth.
Okay, and same problem on both machines, right?
No, right now I'm just having problems on the MacBook.
Did you
I am
download
using
the latest
Blockly Prop
launcher?
Solo.
Okay.
Mm-hmm.
And you have the latest launcher?
Yes.
Too. And I wonder if Jeff were here, if he'd ask about your bandwidth speed. Do you have a pretty good internet connection?
I think so. Yeah, I have a 5G at home.
Yeah.
But no, I wonder if I need to just turn everything on and off like the other person suggested.
It might be good. The Mac is the trickiest operating system for us to support. And so just hearing about these things is important to us so we could dig into it. We know right now we have some intermittent download failing that's occurring probably on all operating systems, but you shouldn't be totally stopped. So we'll just make a note for Jeff to get a look.
And the Mac launcher was updated just 1 week ago.
Yeah, and I downloaded it maybe Sunday.
Okay, good. So that's good to know that that's not it.
Okay, so if you guys have a ultrasonic sensor, let's build a program to graph the display. Briefly, this will probably take us about 7 or 8 minutes. So here's how you go about it. And I'll just guide you from my experience working with it. There are tutorials around this as well. So if you go into the communicate block, first make a new program. Sorry, I didn't tell you about that. Under communicate, there's a graph block. 2 blocks actually. You're gonna need both of these. So one is initializing, and then the other is actually sending the data to the graph. So get both of those things. And you can just leave them separated from now. And then we want to go to sensor. And free to ask me, by the way, if you're missing things, I'm going too fast, just stop me.
And where's the resistor plug into?
Oh, that goes to the I/O pin and then to the signal line on the ping sensor.
So that's going on P15?
Yep, that's fine.
And then is that going to is the other end going to 3 volt?
So the sensor has a 5-volt line, which is the middle. And so the front of it has silkscreen. And then the first position is the signal line. That'll go through your resistor to your I/O pin. And then the bottom is ground.
Okay, so the resistor is going from pin 15 to where?
To the signal line on the ping.
Okay, so they're going across each other then.
Yeah.
Okay.
Yep.
Thank you.
Yeah, you're very welcome. Okay, so grab a ping block, distance ping, and a couple ways we can go about this now. We can actually attach it to this graph block. I think that's fine to do. Let's just do that. And we can choose the units. I'm just going to keep mine centimeters. I'll switch it. And I happen to be on pin 7, so you could choose your own pin. And this label is just that. It's not a variable name or anything. It's just a label for the graph. So I'm just going to call it distance. And I need to put this in a loop. So if you go up to control, and then you find the blue blocks, you want repeat forever. And then you can plop that around the graph block. And there's that satisfying Blockly snap sound. Now, as I mentioned on Tuesday, there are no guards against you flooding the terminal here. And there are other terminal programs you can use. That we make one called Parallax Serial Terminal. It's quite nice if the Blockly terminal just doesn't work too well. But for everything we try to show in our tutorials, it's useful. So I'm going to put a pause 100 in here just to slow down the flooding to the terminal. And then I'm going to connect it to the initialize block. I'll build a little system here that you can see and pin my video, spotlight it for you. In fact, I think I can just bring that video into my main display. So you may be seeing 2 of my videos right now.
I'm still seeing your code.
Okay, just code only. All right.
Mm-hmm. But we're expecting the terminal to show up, though?
Yeah, in just a minute.
Okay.
I'll download, waiting for them to catch up a little bit. And Stephanie, do you see the video that I spotlighted?
No,
It might just be highlighted So if you scroll through the gallery, it might just be that mine is highlighted, but people can change it to the single block view and then get a larger picture of it too.
Oh, I see you mean your live video?
Yeah.
Yeah, you're pointed at a box.
Yep. Yeah. Not much action, just a setup.
I don't know why I was looking for a YouTube video.
Oh. This is the ultimate media assault on our senses. Okay, I'm going to go ahead and load the EEPROM so we could see some results.
Now I want to find a ruler to check to see how close it really is to measuring stuff.
Yeah, you could do that. It's a good idea. All right, so you see now I'm graphing and I'm moving this closer to the box, my Leatherman toolbox. So I'd like you to be able to see the same thing. So when you download to EEPROM, the third button, it should open a graphing window and you should see the data streaming in. And remember, change the IO pin to your number.
And do you ever have to tell the board when a pin is an input or an output?
So these blocks in the libraries do this for you.
Okay.
However, if you want to deal with raw states like driving a 7-segment LED or something, like one of these, the pin states variables or the pin states blocks down in, actually they're right here just above communicate, allow you to set inputs, outputs, and directions.
Yeah, I had seen that yesterday when I was troubleshooting something and then realized that just now we didn't bother telling it that one was in. And
right.
While I have the mic, that demo, I mean, the instructions you showed us had it plugged in, had the ping plugged into 15. But 15, like that's conflicting with one of our servos, right? Like,
yeah, excellent. Good point.
Well, I ran into that yesterday. I had something plugged into 14 and I kept getting this beeping noise and thanks for giving me errors.
Right.
And finally figured it out that those are in use.
Yeah, we're so glad you brought that up because 12 through 15 on the breadboard are also shared with the servo ports on top. So generally with anything robotic, it's advised not to use on the breadboard 12 through 15. Thanks for pointing that out. Yeah, and that's a trap that would catch us. It's something maybe we should have designed out, but we wanted to give we try to find the most flexibility with the most resources. And so once in a while, we set these traps for people to walk into. That's one of them. And it can be hard to figure out what's going on when your servos are jittering and your sensor's not working right. But
where is that example that's using pin 15?
it was just from the help reference for the ping sensor.
Okay.
Who'da thunk? Okay, so who's got this graphing? Thumbs up? Okay, we got Chris's thumbs down. Let me get a few more. Graphing successors. Anyone else? Okay, good, good, good. All right, and let's just look at Chris's problem then. Chris, what are you experiencing?
So I plugged into, I have my, wait, I think as I'm describing it to you, I think I realized what I did. Yeah, I mixed up my signal and my 5 volt.
Okay, good.
I'm gonna fix that right now, then I think I'll be fixed.
All right, so once you've done this, you can now take the ping, point it a little bit down, move the object out of the way, get a feel for what it will see and not see. You can also go to the product page, look at the documentation, read about the cone that it detects up to distance, and start to understand how these sensors really work and what they're capable of. So for example, if I take this ping and I turn that box sideways and I try to graph it, let me bring that up again. Oh, wrong picture. I want the graph. Oh, I have to reload it to start the graph. I'll give you an example where the ping probably doesn't work very well. Okay, so it's reading 16 inches, but there's a box right in front of it, and I've angled the box. So the sound is bouncing off the box and probably going to somewhere else. If I turn the box the right way, I now realize the box is 10 centimeters, 11 centimeters away. Okay, so all I had to do is turn it, and the signal now becomes garbage. Okay, 13 feet. It's not getting a reception back. If you take a stuffed animal and you put it in front of the ping, it will absorb the sound. If it's a real plush, furry one. So when you're working with all these sensors, you can use the graphing capability to see what's going on, and the terminal like we show you in the tutorials, and take your time using it in different situations. If you're using infrared and your emitter and your receiver are not pointed in the same direction, the receiver will not receive any reflection of IR light coming from the IR LED. So that's why we like to do things with the ping, like put them on a servo like this and be able to rotate them. So spend a lot of time, before you use this in class, because students will give you every possible situation. And you want to have a little bit of information to answer some of those questions. So you have whiskers, you have an ultrasonic sensor, and you have infrared emitters and detectors. You have 3 kinds of sensors you could be using. So is that helpful to see the graphing? Yeah? Okay, do you like that? All right. And you can yeah.
I really like it as being a physics teacher, of giving my students a way of seeing how their veneer equipment actually works for their ultrasonic sensing.
Yeah, you can put them out of business now and make your own equipment.
Yeah.
Yeah, so you can graph multiple channels as well. If you click on the graph block, like I'm showing you right now, check this out. You can bring in more and more values from different sensors. All right, but I forget how it handles the axis, if it uses one axis for all or not. I don't remember. I'd have to look at that. But for things like the light sensors, this is very helpful too. And you can try reducing this pause to something that, doesn't work. At some stage, it may not work. Or it will exceed. In this case, if you went down to a millisecond or 2, that pause is not probably enough to get a good reading from the sensor. Maybe you're getting the last reading, or it doesn't buy you anything, I should say. So experiment. And this is what's different about Blockley Prop from a lot of other robots. You're starting into an ecosystem that's really huge. And we've supported just about everything that we can with this system. So exploring and going outside of the tutorials is really important. We're pretty confident by now you can already build up and wire circuits and then drag blocks in and create code. So are there any questions so far? Because the next thing I want to show you is also a little bit unrelated to the tutorials, but it involves music. Okay, cool. All right. Got a double thumbs up. Okay, so about music. Several of you asked about music, and I showed this briefly, but it didn't work too well on YouTube, so I just downloaded it and I have it handy. Music has note values, durations, and rests in it. And pretty much this frequency block that I'm highlighting takes care of 2 of those 3 pieces, the note duration and the frequency of it. So what I did with this project is I went and grabbed the Super Mario theme song, and I found online so many nerds that already translated into notes and durations and rests. And most of the stuff has been done already for anything that's remotely popular. So typical student approach is to take frequency blocks, string them together. Maybe or maybe don't have pauses. I don't know if they really are going to read the music and translate it properly. But here we have one frequency block and arrays. And we're indexing through the arrays with a variable called item. And so the first number in each of these arrays is the note, the duration, and the rest. So through each loop counter, we're indexing the same number in the next position, the first position, the second, and then the third. And then simply dropping that arrayed index number, or the number occupying that indexed value into this frequency block. Okay, so this is a lot easier way to do the happy birthday song that I saw. So I'll just give you an example of what this sounds like, provided things work right. Okay, what'd you think of that? Does anybody remember being stuck in an arcade playing games in the 80s with quarters lined up on top of Donkey Kong? Okay, so I will send this program to you and this will answer all of your music questions, I believe. Anything else? Yeah.
On a question on the frequency pin, what setting does that pin have?
Oh, yeah, I'm so glad you asked. So you have a piezo speaker in your kit and you can use any of the pins 0 through 15. Just put that on your breadboard. And just remember, if you use 12 through 15, it's going to conflict with the servos. I'm using pin 27 because you can plug in, like is shown here, a little speaker and amplifier. The activity board has an amplifier on it. So it's great for louder sound. You can put your earbuds here or a small speaker on this amplifier. And the board is labeled. If you look carefully on the propeller activity board where it says AV, just under the word activity, I have plugged a speaker in there. And if you keep going down, it says P27. And it shows a little set of headphones. Yeah, thanks for pointing that out. So I'll tell you what I'll do then. I'll just change this to pin 0 for you. That way when I save this off and send it to you, you'll have a better chance of getting it working. Okay, so there was the idea of playing sound while you're roaming. And I think, Andy, how would you do that? Just throw this into a new processor block?
I am uploading an example of that right now. I'm just about to share it over the chat.
Okay, cool. And where's this example going to be located?
It'll be in my Google Drive. You can download the SVG and then open it with your editor. And all I need to do is share it into the, will you be able to get it if I share it into the chat?
Yeah.
Okay, just a second.
So once that shows up, and the reason we'd like to show you this is because the propeller can do things in parallel. We take questions while Andy gets that ready.
Is the pin 27 for audio different from the pin 27 for the LED below the circuit board?
Oh, you saw that blinking. So yeah, they're sharing. Since the LEDs just say output device, we were able to stuff it on there and share the pin that is with the audio amplifier. That's why you saw that flashing.
Okay.
Okay, so I just shared it. Let's see if you can right click and download that.
Opening it up right now. Putting it to the desktop. And I will go ahead and open it.
I might have been a bit verbose with the name and it got truncated.
Oh, look at you go. Okay, maybe we're going to want to share this with the group as well then. I'll email it.
Yeah, this is a nice one because it basically
Perfect.
shows how to play music at the same time that you're navigating by using one of the propeller's other processors to play the music while you're navigating in your main thread.
Oh, this is wonderful. Okay, so what Andy's done is he's thrown a new processor block in the top of the program. And this is standard approach. This is how you use the new processor block. He created a function, and that code will run as soon as this new processor block is encountered in its own parallel. So that'll start and go, and then the next line of code will be executed. So that would be sound with movement. In fact, I think we could just load this up and run it on my robot. So I'll grab.
While you're doing that, I had students who, well, they always seem to struggle with just what is sine and what is cosine, right? So with this little the simple distance program that we have, one thought that went through my head, I don't know how much it would help them, is that you could have a cosine graph on the board and a kid with a book and have them try to match it, walking forward and back toward that little robot. So they get the idea that we're reporting horizontal distance that way.
That's really cool.
Great.
Yeah.
And I just think that might help them connect that, oh, that graph is telling me horizontal distances, because I think they get vertical ones a little better. But the idea that you're graphing a horizontal distance on a vertical axis is always a bit of a hoop to jump through, or a hurdle to get over.
Sorry, Ken, all I had was a piezo speaker.
I'm going to let this run so we could see it do things at once. It's going to be pretty loud. Okay. Was that do, re, mi?
Yes, just plain old solfege.
Okay, we'll restart it.
Okay, so I ran it once and there's a coding error. I forgot to put that whole thing in a repeat loop that's endless. If you were to snap in
on this?
Yeah, exactly. If you snap that in, then it will play over and over again as intended. There you go, perfect.
Okay, and I won't demonstrate it because my colleague will get furious with me for the first time. All right, y'all got the idea, do ya? I mean, this is pretty advanced. We're just kind of pushing you beyond the tutorials here.
How many processors are there? Sorry to interrupt.
There are 8. Yeah, and we covered part of this last Tuesday, but it doesn't mean that you could do 7 new processor blocks here, because we have some usage of processors with these blocks, robot drive speed. And Stephanie, maybe chat in the link to the reference page that shows us which blocks already use processors.
Yep.
So yeah, you
Right
can
there.
basically subtract out the blocks that use processors and then see what's left to use your own new processor blocks. But if you tried something like, just to give an example how useful this is, and she's putting that in chat, if you just wanted to blink 2 LEDs, pin 26 and 27, we're just going to do this really fast because I want you to see this. And then I would ask you how you would do this in an Arduino, and you'll spend the rest of your career maybe figuring it out. But let me start a new program briefly. So just going to make a really simple program with 2 new processor blocks. And then I'm going to get 2 functions. I'm going to call it P26 and then P27. We have tutorials covering this, by the way. And within each of those, I'm just going to make a repeat forever loop. And then I'm going to go to pin states, and I'm going to get the make pin block. And I'm going to set 1 to 26, because these are the built-in LEDs. We're going to use toggle, so each time through it changes whatever state it's in. and then put a pause in each of them that is different. So how do you blink two LEDs at two different rates? So I want to blink one at 327 milliseconds, and I want to blink one every 326 milliseconds. And I'll show you the results of this. So the reason this becomes relevant is with robotics, sometimes you do want to do more than one thing at a time. And a quadcopter is a perfect example. While you're flying, you're checking your gyroscope, checking an altimeter, driving motors, checking an RC radio. And if this stuff can't happen in parallel, you don't have a tight enough control loop to fly the quadcopter. So let's download this and then look at the LEDs. And it might not just be LEDs. I mean, this is a very simple way to do it, but suppose you had a GPS sensor. We have GPS blocks and you want to get the data from it. But you don't want to miss it because you're busy doing other things. So these LEDs start out blinking together, but in time, and it might be a good idea just to make it a little more apparent. Like, let's just say we'll make one 100 and we'll make one 99. We'll download that. So they start out blinking together, but in time, they're alternating after, I guess they'll be out of phase after 100 cycles, like you're seeing now. Then eventually they'll blink together again.
Sort of like multiple blinkers when you pull up to a red light.
Yes, same thing. Yeah, so fun with LEDs. What do you think of that? Do you understand what we just tried to communicate? Thumbs up or thumbs down? Oh, wow, okay. All right. So where does that become useful? I think you find out when it's useful when you run out of ability trying to do two things at once, which can happen. Okay, so let's move on, unless we have questions. No questions, okay. The next thing, Andy, Stephanie, any input so far? I was just going to go into some of the projects and then teacher material.
Oh, I think we're doing well.
Okay.
Yep, that sounds good.
All righty. So what is possible here with Blockly? I'll show you an example of something I have made. So I want to really encourage you to use Blockly with your students for things well beyond robots. And as you browse around the blocks, you will see that you'll ask questions and then you'll run into different hardware you make and get some ideas. This particular contraption is a visual metronome. Anyone out there struggling to play an instrument for the first time over the age of, let's say, 30? Come on, admit it. It's hard, right? Yeah, so, students have the ability of that growing brain and they can keep time better. And I totally have struggled with this playing clarinet. So I made a visual metronome. So that the clicking was driving me crazy. So I decided that I would make something that has lights. Yeah, you like that, Linda? And it also does have clicking if we want it. And you can set the frequency or the tempo with this dial over here. So this would be prestissimo, 260 beats per minute, and set up for 4/4 timing signature. That's why the first one is white. 1, 2, 3, 4, 1, 2, 3, 4. See, I can hardly even count, let alone play a clarinet to match this. So it's really difficult. And there's a little display in here that shows you exactly how many beats per minute it is. So just one example. And this project I was able to put together in 24 hours, actually. Things like this, there are displays that we have blocks for. There are sensors of all kinds. So give that a look. As far as the ActivityBot is concerned, when you click on tutorials and then you come into the By robot or kit, I'll choose ActivityBot. You will see projects of all kinds with Blockly. So these are all projects that we're looking at using different things. Some are infrared. Looks like there's a joystick controlled. Here's the color object tracking thing that I've been messing with that you've been seeing the last couple of days. Not entirely written up yet, but it's coming. So let's just grab a look at one of these. PingDAR display. Okay, so this one demonstrates how to mount the ping ultrasonic sensor on a servo on top of the robot. And for the whoever was talking about the trig, here you are. This is built in the Blockly prop as well. And this prints a radar style display. I think the first picture shows it best. Oh, maybe there's no video of it. That's okay. Yeah. So how do you relate these various tutorials that we have to the hardware and not scramble around trying to figure out what we have? So when I click on the home page and then I click on ActivityBot, I get the view that I really like, which is the prerequisites, the main lessons, and the projects. For the projects below here that you see, there are 3 that are included, for which hardware is included in our 12-pack plus, which I'll bring you to in a minute. One is the infrared remote control. It's the first one. And then also the line follower hardware is included and the ping is included. Okay, in what we'll call the 12-pack plus. I'll bring you there in a minute. You have everything for the standard kit right here, and you can do all these projects, so roughly about 40 hours. So what teaching material exists? Let's look at that. I'm going to log in, and if you don't have a login yet, just keep emailing us. It seems like half of them got caught in spam filters or didn't arrive. Who's still awaiting a login? Give me a thumbs up if you're awaiting a login. So most of you got it. Okay, so Joel needs it. All right, so once you've got your login, you can come into learn.parallax.com/user. We'll give you the link and then log in and then click on Educators and scroll down to ActivityBot Resources.
I'm sorry, which Joel was that who still needs a login?
Joel Slager.
Okay. Did you check your spam filter or do a search for it? Oh, you're muted.
Sounds like he's checking it.
Oh, good.
Okay, so what do you find here? This is something Stephanie maintains very well. One of our favorite resources, the scope and sequence. And this will show you how to paste this material out in your class. So get out your magnifying glass and give this a good look.
There should also be a Google Sheets link there too.
Oh, great. Do you want to talk about this document for the moment, Stephanie?
Oh, I guess I could. It's on your screen though. So what we've done is we've broken this down into units and described about how much time we estimate it should take, the skills, the concepts and objectives that you do you gain in that lesson. There are suggestions for making it a little longer or shorter if needed, and then all the resource links for that particular unit are right there at the bottom, whether they are linking to a web tutorial or to a video, and sometimes for the projects, additional hardware that's available in the shop. And at the top, you'll see a purple bar and a little tan bar. And that just says that if you've got a 12-pack plus, which is Ken will show you when we go through the kit purchasing options, that says if you bought that 12-pack, then you already have this included hardware. Or if you bought individual ActivityBots, it'll show if you bought just the individual robots, if you want to do those extra units at the end, that's the additional hardware that you would need. So it's just a quick way to match your goals to the hardware you have.
And I think the state robot kit, 30 hours, is kind of what I hear.
I'm sorry, was you and Andy?
Oh, I mean, 30 hours, 30 to 40 sounds about right. And then I have a quick all points bulletin that anybody who wants to download and try the play music while you drive around example, I posted an updated link with the loop added so that it continues to play Do Re Mi over and over again as it continues to navigate.
And if you need to provide standards alignment, that document is also available, aligned with Common Core State, ELA, Math, NGSS, K-12, Computer Science, and then some CTE standards and 21st century competencies. So this is a big, long document. But I think one of the most useful things for teachers is actually the assessment material. So it's available both for Blockly Prop and C. And this is nicely designed in a way that it's not, it's kind of agnostic to the fact we're using a Parallax Propeller ActivityBot 360. And the terminology is very general tech style language. So I'm going to download that and get a look at it and see if, okay, so here's an example. And this is available in RTF format, so you can edit it, or PDFs. A normally open switch is a switch that is open in its active state. Oh, here we go. Okay. Which diagram shows an activated circuit? Andy? Okay, that'd be circuit B. All right, so anyway, the answers are down below and they're in red, and you can just not print that last page, last couple pages, okay? So this is what you get with your educator login. Other things I'd like to show you that I find tremendously useful in working with this. Let me switch over to where I was actually. Okay, so Blockly Prop has a good community of users out there, and there are a couple ways to reach them. One is on the Parallax forums, which are forums.parallax.com, and another is on this Facebook group, Blockly for Microcontrollers, which I mentioned. I see actually already several of you jumped in there, which is cool. So I admitted you right away. There are about 1,000 people on there, and there's some really good engineers too who just seem to have nothing but time for this. So take advantage of that resource. The Educator Hotline is open all the time, and this is a no-nonsense direct to Parallax key staff, and that would usually be me answering it 12 hours a day. Lately it's been going. In fact, it was ringing just now, and they're all going to voicemail. So I encourage you to use this when you're in class and you're stuck and you just have some technical problem, Blockly's not working right, student has a question, it doesn't really matter. You need a quote, that's wonderful. Just call this and we'll take it. I don't want you have to even compose an email if you don't want to. I know you're absolutely busy, so feel free to use that. So before I show you the hardware kits that are available, I should also just briefly draw attention to this kind of thing. We attend the Google Blockly conference each year, and Google's challenge is always, hey, show us real world stuff, you know, that you're doing with Blockly, because Blockly can control machines just as well as any text-based coding. And it can control big things or little things. It doesn't have to be a little robot on your desk. So they're interested in that. And I have done some larger robot projects with Blockly perfectly well. This one's from our customer. This is a buoy that has some sensors on it for air quality, motion, GPS, and it sits in a bay in Maryland from one of our customers, Wayne Green. And this is two different projects done in Blockly. The first thing on the left is a quadcopter that's used by some farmers, and they have a business called Dropcopter, and Dropcopter distributes pollination over almond orchards. So it turns out with the bee situation being what it is, we can buy this white synthetic powder that's $1,000 per kilo, and you can put it in this hopper, and this whole system is controlled by a Parallax flip multi-core microcontroller programmed in Blockly. And it has on it an LCD, a brushless motor, and some sensors going back to the radio, just measuring the pulse widths from the radio, and allows them to spray pollen all over the place. Another project is this 3-foot by 4-foot robotic boat, which I've created to navigate in Lake Tahoe over GPS to take water temperature samples. And this is a project in the works, but it's being done 100% in Blockly with GPS. There are videos for both of these things on our YouTube channel. So you can go poking around. We, from time to time, we'll just bring these up and put them in our communication with our customers too. Okay, so how do you get going in this hardware-wise? So you have this kit. It's fine, great way to start a class, or you can get the 12-pack, which is this, 32612. And they are $3,600. We discount things off of the individual unit prices, but it includes 12 of everything, line followers, IR remotes, loads of rechargeable batteries. I think we even have in here, Stephanie, some extra electronic components.
Yep, we have a few packs of the electronics baggies just for replenishment, and also of the hardware baggies for when, you know, that key piece rolls away down between two cabinets where you can't get to it. And eventually the resistors will get a little bit mangled up too over time. So everything that you see there is available separately as well. And there is a page on our site that has just all of our kit and accessory options together. And I'm putting that in as a link to bookmark for later as well.
We'll open that up and get a look at it. This page, correct?
Yeah.
Okay. Yeah, and we're not a sales pressure organization, as you already know. We'll just actually ask you if you need any help purchasing, but that's about all you really hear from us. And we from our experience, teachers who learn this want to use it and end up using it. And then we just support them for many years to come. And you will find the hardware does not get obsoleted. It should not be dust collecting, and it should always work. And we're always happy to help people get it up in a working state if something's not right going forward. So that's our guarantee, aside from being made in America. And my final sales pitch to you is that this can make your classroom the one that your students remember. I would have been thrilled. All of us probably would have been at Parallax to have such things when we were students. I mean, this is amazing because we had a good time just making a cursor plop across the screen on a Timex Sinclair. That was fun. I mean, imagine this.
With a little logo turtle.
Yeah.
Drawing little spirograph designs with it.
So I think we've covered everything we can in 3.5 hours this week. And what kinds of questions do y'all have that we've not answered? Oh, how are the kits
like the
stored?
latest.
Yeah, okay. So how are they stored year after year? Many teachers opt to have the robots taken apart at the end of the semester because students like putting them back together. My advice is to do something like this. You could use the box for the robot, but for your personal component management, make a trip to Walmart, get a Plano box that has dividers in it. And I typically see the components being kept kind of at the front of the class and then distributed each day as used. So the robot ends up going in the box, the components go in the Plano boxes. And the curriculum is located on learn.parallax.com. And just click on ActivityBot. And Stephanie also just pasted it in there. Yeah, please, Chris.
About bouncing back and forth between code view and block view. It doesn't look like you can edit it in code view, and I didn't even think I could copy paste it out of code view into another text editor. Is that right?
You can. You should be able to copy it out of there and into simple IDE. We do it all the time. It's part of how we look at when we're creating new blocks. It's part of how we look at the code generated by the new blocks and then can test it in simple IDE and then look at the compiler errors we may get there to see what we're doing or what we missed when we're developing. So we do it Just to say that because we do it all the time.
But let's say you have a project that has libraries and things, just that
Mhm.
text file is probably not going to help you. So if you click on code and like I'm doing, can you see my screen for the moment?
Let me go back.
Yeah, just follow me. We'll actually take this project right into Simple IDE.
We keep the libraries that are used to make Blockly Prop go, and the library, the Propeller C Learn folder that you can download for Simple IDE. Every time we do a major update to the libraries behind Blockly Prop, we also release a new version of the folder that Simple IDE uses for libraries. So if everything's up to date, it should work to move your C code over.
Okay, so you do I just need to copy it out, paste it. I had, before you showed us the arrays for music, I had done line by line happy birthday for my daughter the other day because it was her birthday. And I was coming out of like a pin number, like 14 or something. And I was like, I just need to change all of these pin numbers to a 7. And I wanted to do it with like a find replace, but I couldn't figure out how to do that very easily. So that answers that question.
Yeah, which brings us to your projects, actually. We have some videos to show.
Good.
Before I forget. Yeah, so do you want to see just a two minute or 1 minute demo of how I get things in Simple IDE? Chris, this is what I do. Okay, so here's the code.
Here we go.
So if you click on the hamburger menu and then you download Simple IDE files, because as you noted, you cannot edit here.
Right.
So I'm going to download Simple IDE files. I'm going to save them on my desktop. They're coming down as a zip. And then I'm going to go to my desktop, unzip that zip. And it makes a folder that has both the C file and the project file for Simple IDE. So if I click on that project file, it opens up in Simple IDE.
Oh yeah, that's the better way to do it.
And now you can edit.
Is that a variation of C, or is it just purely C? Or
It is pure GCC, and it's been adjusted only slightly because the output it has to generate is something that the Propeller microcontroller needs to be able to understand and execute. But aside from that, it's standard ANSI compliant C. The libraries, like if you look up top at lines 2 and 3, there's a simple tools.h and an abdrive360.h. Those are custom libraries, one that supports general Propeller programming and then the other that supports the ActivityBot.
Gotcha. Okay. Yeah, I was just curious because currently there's other brand name robots in my classroom that I won't name. And I am a little frustrated sometimes with the proprietary languages. So. Just curious.
Oh yeah, this stuff is all
open source.
Yeah. In fact, even this Propeller activity board and the Propeller chip itself, I believe, is the only fully open source microcontroller out there. You can load the design and run it in what's called an FPGA board. So last thing, our awards. Oh, by the way, here's another really cool thing we didn't show you guys. Circuit overlay board. This was invented by a teacher for us, and I'll also draw your attention to the camera for the moment. So what you can do if you don't like to breadboard these super complex circuits, which happens a lot with the ActivityBot because it can do it, it can manage things, you can actually solder them on these little boards. Okay, and they match the breadboard shape. So here's one with an LED on it, and if I just want that whole circuit to be available, I can simply plug it onto the ActivityBot. So some teachers will build up every circuit we make, and this allows them to demonstrate it without having multiple ActivityBots.
It's also a good way to have a spare robot to pop in a known good circuit, give it to the student to go and try their code, and they can quickly troubleshoot and figure out if the problem is in their code or their wiring.
Okay, so we had a contest. Here's what we got back. At least what we're able to track, because between the three of us, as I mentioned, we had 2,000 to 3,000 emails in the past week that we were managing. 3 categories: funniest animal or coworker, category 2, biggest fail, and then category 3, biggest winner. And Alan Dwyer submitted this. He's having a mutiny problem at home as his kid is taking over the situation, clearly. And Jeff submitted this. Funny coworker or biggest win. This is really, you guys are going to have to vote. I'm not going to tie break this. So let's just get this out of the way. They're both coworkers. Let's take a poll. Alan Dwyer, thumbs up. Okay, Jeff Rupp, thumbs up. Okay, Jeff, you're the winner. The robots beat out the humans. I don't want to be thinking about this thing at 10 p.m. tonight, so I'm going to spend the day scrubbing this image from my mind. It's evil cat. Just ready to go from being petted to chewing your arm off. It's a great robot. So look for that in our social media. Is Joel Bunt here?
Mm-hmm.
Oh, Joel, maybe you want to tell your own story. Because this is an expensive fail.
Yeah, I'm not so sure I want to share my story.
These are just the quick notes I took as you were describing it last time.
The backdrop is that years ago we found our way out to an acreage, and it took about all the money we had. So most of the equipment I have is donated, passed on, which implies that it never works and causes great stress. So I needed to get my mowers going, and one battery seemed to, even when I put a trickle charger on it, it seemed to not have enough energy. So jumped it, the kids jumped it from another mower so that I wasn't putting too much juice through it. Kids used it for a day, the next day it wouldn't start, and I thought, oh, let's jump it again. I don't want to fight with this thing. And either in my hurry or my lack of attention, I noticed when I connected the jumper cable that I got a lot of spark, and that should have immediately let me know something's amiss in mower land, but I just ignored it and kept going. And I pretty quickly noticed that the jumper cables were getting hot. So that's kind of what happens when you go ground to live to ground. It doesn't.
You made a welder.
I made a welder. I did make a welder. So then I was like, oh, crud. I think I had a bad battery and a good battery, and I think I ended up with 2 toasted batteries. So I went in town, got 2 replacements, put one in, it worked wonderfully, put the other one in, and while I'm putting it in, I dropped a nut, and then my open end, closed end wrench flopped over and created an arc across the 2 terminals. So then that battery was useless as well. So fortunately, they're mower batteries, so we're not talking $100 a piece, but it wasn't as if I cared to waste that much money. But
ouch. Well,
that's how it goes.
By being the biggest loser, you're now the biggest winner. Congratulations.
And there's a consolation there, because then maybe instead of just throwing my money down the drain, I redirected some money.
Ouch. Okay, then we also got some videos in here. So let's get a look at those. The first one will be from Chris Ammon. And I don't know if you can hear the audio because I have my headset on. Can you hear that, Stephanie?
I cannot at the moment.
Okay, I'm going to unplug my headset.
To make sure everything works.
I think you might have the audio muted on there.
You still don't hear it?
Nope. There we go. Barely.
Okay. Several audio controls, so we'll play the highlight again here.
Yeah. Did you hear happy birthday there?
Yeah, good job. Okay, so that was Chris. And so Chris, you now know how to do this in parallel with motor control. So, and you can do it with arrays as well. All since yesterday. And then
that's not the easiest song with its timing and its sharps and whatnot.
Okay, so here's the roaming spaceship. And here's another example of something that can happen in parallel. He wanted those wings to retract while the robot was rolling around. Right, Alan?
Yeah, I got him to be able to open and close at the beginning, but as soon as it started, even using a second processor, it just stayed open.
And it might be one of those things we just have to help you with, or, you know, the blocks aren't as clear as you think, but it can definitely be done.
Yeah, with the, were you using a standard servo to retract the wings?
Yeah, they're little blue ones. I don't know. I don't remember the name of them.
Okay, just so you know, there's no need to put that into a separate processor. You can just tell the servo what you want it to do from the same thread that you're controlling the robot. Unlike the speaker, it will, the servo will automatically start another processor to work with the standard servo.
Okay.
And that single processor will do up to 14 standard servos if you want.
Okay, and so now we have Matt Lindsay's robot with his dog. His dog is curious as heck, but he does not attack.
What is that? My brother. It's okay. It's a robot.
So pretty good. And I believe we chose a winner. And that winner was Chris. Yeah, it's Happy Birthday Robot for his daughter. And also Chris pointed out here, we already talked about this, but pins 12 through 15 are shared with the motors. So look out for that.
And thank you for pointing that out. I have made a big red exclamation point note right in the reference for that example. So hopefully no one will run into that again.
Great.
Yeah, so I hope you all enjoyed the online training this week. It was a first for us at Parallax.
I think it was great. Thank you guys.
You're very welcome.
I do have one quick question. What do we need to do as far as sending software to our kids' computers? Will it download nicely, or do we have to download each computer separately?
Well,
the launcher does need to be resident on each computer. It can't be run from a central, it can't be managed from a central place because it's managing the USB connection on each computer. So you do need to have admin. For that, there is a Blockly Prop FAQ for schools that's written that tells IT departments a few things they want to know. And the launchers
So could they
are
scope
on that page 2.
Could they scope it to a Mac and then they use their Launchpad to do it or not?
I'm not a Mac person, so I don't know what that means. So I don't know what scoping to a Mac means. I'm sorry.
They send out software to every single computer, and then the students are actually downloading the software themselves.
Oh, I don't know. If you want to send an email to support@parallax.com and put attention Jeff in there, he's our senior software engineer, and he would be the person who would like understand what you said and then have a really in-depth answer or questions for you. Okay. And may end up saying, hey, would you like to test drive this with me?
The typical scenario is just that the IT generally services requests for, gee, I need software X, Y, and Z to be installed resident on the lab computers. And then there are other softwares that don't need to be there. So for the softwares that need to be installed, the Blockly Prop client is normally one of those.
The launcher now.
Pardon me, the launcher, yeah.
Yeah, just one install. And then one more thing about that, once you start Blockly Prop Launcher, it opens that window. You can work in that, or you can go to a browser tab and close the window it started. But no matter what you do, you must keep this open. So this window that it opens up, when you click on Blockly Prop Solo, you can close that if you want and just type in solo in a browser, solo.parallax.com. That way you can work exclusively in a browser. All right, good. Yep, and no student logins or passwords required. All file saving is local.
Mm-hmm. And that last link I sent, there's a PDF for download there that explains those things.
One more quick question. When you save, is it always going to ask you to rename it even though you've already named it?
Yeah, it'll just give it another revision number.
Okay.
And it'll try to save it with the subsequent number until you change it.
I think part of that's also browser settings, as far as whether it's going to ask you to rename and choose a location. That has a lot to do with browser settings.
It is kind of a nice practice to show the students, though, that they have enumerated versions of, if they save frequently, they'll have enumerated versions, and then they can grab the one they want to keep and copy that over to their folder and let the rest just kind of fall into the downloads that are never used again.
Or they can save over the other one if they have the option to rename.
Okay, any final questions or comments?
What's the advantage to, like, when you click the Blockly Prop Solo and you said that window opens, and then you said you could close it and then go open it in a browser? What's the advantage there?
I just like working in a browser because I'm not alt-tabbing between two applications. And usually everything else is done in the browser. I just find it a little easier to organize workspaces. There's one more thing too, which is you can put windows side by side a little bit easier with multiple tabs open. But it's just a preference. Probably because everything we did in the past with Blockly Prop was a tab in a browser, and I just became used to that.
Yeah.
Totally up to you. I mean, maybe the confining aspect of this is really good for students, right? Because they're just stuck right here. Not
yeah.
on the web page. Yeah, the difference actually, there is a difference technically. When you open it as Blockly Prop Solo, this version is actually a self-contained Chrome application that has all the necessary pieces of Chrome combined with our app. And when you run it in the browser, it's different pieces that are also working together. I don't really know how that affects it performance-wise, but.
Any browsers recommended over others?
Oh, you have to use Chrome. Have you been getting by without Chrome this whole time?
I've been using a Chromebook. Well, I have both of them up. The Zoom I have on my Mac, and then my Chromebook is what I've been programming on.
Yeah, Chromebook, Windows, Mac, all good. Chrome browser on Mac and Windows is required. Okay, well, we want y'all to have a really good rest of spring. We know you're working hard at Parallax. We see it because we read your emails, and don't feel unproductive. It's a situation you can't control. Just keep doing your best, okay?
Thanks again.
You're very welcome. We're ready for you if you need us.
Thank you.
Perfect.
All right. Have a
Appreciate
good
everything you
spring.
did.
Thank you.
Stay healthy.
Thank you. It's been great.
You're very welcome, Bob.